What's up? I'm already here. I'm already doing this, and it's kind of late, but I'm just going to go ahead and talk about decomposing numbers because that one needs to be talked about, and I can just take care of that. Okay. Decomposing a number. That's the technical term for it. It means that any number can be broken up into an infinite amount of ways to express that number. So, okay. Maybe I don't even. Sorry. I'm actually not there yet, but I'm going to leave this up. I'm going to come over here. Every number, when you think of the value of a number, what does a 2 mean? What does a 2 represent? A 2 represents 2 ones. Okay? I have 2 markers because I have 1 marker plus 1 marker. So instead of writing the Roman numeral for 2 that actually has 2 ones, we just have a number. We have one number that represents other things. So instead of writing out 5, this is how they wrote out 5 for hundreds of years. Roman numerals were a thing for a long time. You had to write out physically 1, 2, 3, 4, 5. You have 5 tally marks to represent the number 5. But instead of using 5 hand strokes to represent 5 items, they came up with 1 symbol to represent 5 numbers. So instead of writing this, no. Okay. See how long that takes me to write every single one of these? But essentially, this is what we're saying. When I put 2 plus 4 equals 6, what I'm saying is 2 plus 4, I can't, hey, what do you know? Don't mind the black one. 2 plus 4 is 6. So when we write 2, this is just a different way of writing this. It's a lot faster to write 1 squiggle instead of 2 squiggles. You know, everything's just a squiggle. We just assign meaning to the squiggles. So instead of writing out 1, 2, 3, 4, 5, 6, 7, 8, 9 every time that we want to express 9 of something, we just have 1 little squiggle that we can make instead of having to write out 9 individual lines. So 9 means 9. Okay, I'm going to leave this up for a second. Maybe I'll just change it. I'll make it a little smaller. Two plus 4 equals 6. Now, when you think about this, what are the different ways of expressing 2? Nothing really. You just got 2 ones, right? The number 2 just has like 2 ones. That's the only way to express it. What about the number 3? Okay, a 3 is represented by 3 ones. But with a 3, we can represent this as 2 ones plus 1 1. Because that 3 has, or we can write, oh, there's another way. 1 plus 1 plus 1. That's another way of expressing 3. 1 plus 1 plus 1 is equal to 3. So we got, don't forget 0. 3 plus 0 is equal to 3. 2 plus 1 is equal to 3. And 1 plus 1 plus 1 is equal to 3. So whenever you're doing anything with math, you can break numbers into their smaller parts to make them easier to work with. I'm going to be decomposing addition and subtraction, and I'm going to be decomposing multiplication and division. Okay? So when you have, let's do 5 plus 8, right? 5 plus 8. Well, what's this even saying? We got 5 little tally marks, and we've got 8 little tally marks. So you can count up the tally marks to see that this is 13. But an easy way of thinking of this is decomposing the 8. Well, okay. Before I get into this, what are the decompositions of 5? We have 5 plus 0. I'm just going to leave this out because y'all can figure that out. 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, 0 plus 5. Every single one of these equals 5. So when we run into a situation where we have a 5, you can just break that 5 up into any of these. So what are the, instead of repeating myself, I'll do the 8, okay? You have 8 plus 0, 7 plus 1, 6 plus 2, 5 plus 3, and 4 plus 4. I'm not going to flip-flop it like I did this one, because this is just reverse of this. So with this 8, all of these equal 8. And I mean, if we wanted, you could break any of these down even further, you know, because, oh, what's that? I have a 5 plus 3 is equal to 8, right? But look at the decompositions of 5. So 5 plus 3 is also equal to 2 plus 3 plus 3. 2 plus 3 plus 3. Because 5 can be represented as 2 plus 3, because that's still just 5. And 8 can be represented as 5 plus 3. So you replace that 5 with this one, and you have 2 plus 3 plus 3. And guess what? That's going to be 8. You could break this down into its simplest form. 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, I don't know, I lost count, is equal to 8. You can just break it down into ones if you want. When you have 5 plus 3, you can just break those numbers into anything that you want to make them easier to work with. You can just do that constantly. So with addition, it really helps to take things to the tens place when you're adding the second set and you're jumping over into the tens place. It's really easy to decompose a number into one that's going to equal 10. So when you have 7 plus 8, okay, we can see that that's going to jump 1 in the tens place, right? And so 7 plus 8 is also in the second set of 5s. It's between 6 and 0. And so they're a little bit harder to work with because they can jump into the tens place. And so 7, well, what can we decompose that into where we can get up to a multiple of 10? Well, we can put this as 5 and 2 because 5 plus 2 is 7. So let's represent 7 as 5 plus 2. Let's represent 8 as 5 plus 3. Why not? Why do we keep messing up on that? Okay. 7 plus 8 is the same thing as 10 plus 5. You just changed the values to make them easier to work with. Because when you have like 5 plus 6. 5 plus 6, right? 5 plus 5 plus 1. 10 plus 1 equals 11. 5 plus 6 is just 5 plus 5 plus 1, which is just 10 plus 1. So you change 5 plus 6 into 10 plus 1. Why not? So when you start working with decomposing numbers, it just makes addition and subtraction like so easy, because let's say I have 12 minus 7, right? Okay, well, what's 12? We'll call it, you have 10 ones, and then you have 2. Okay? Well, what's 7? Well, 7 is 5 ones and then 2 ones. So you mean to tell me I can just do 12 instead of 12 minus 7 and trying to think of what's 7 away from 12? Instead of like trying to do 7 minus 12, you just break 7 up into 2 and 5, because 7 is just 2 and 5. So 12 minus 2 is 10. Now you just have 10 minus 5. It's 5. Let's do it. Twelve minus 7. Okay. Well, you can just, I put plus. Because 7 is just 5 and 2. So 12 minus 2 is 10, minus 5 is 5. Because 12 minus 7 is 5. So whenever you're like subtracting or adding, and you're going to be making that jump between the 9, 0, you just break it into its closest 0, its closest 10. So let's do 17 minus 9. Right? 17 minus 9. So how can I break this 9 up to where I can subtract this and get a 10? So 9 is 9 plus 0 plus 1, 7 plus 2, 6 plus 3, 5 plus 4, and then it reverses. So 9 can be represented by any of these. and I'm not going to do it, but we can break these up. I already showed you can even break it up further. 9 breaks down into 9 ones. 1 plus 1 plus 1 plus 1 plus 1 plus 1, 9 times. You're just adding some of those ones together. So we can add 5 of those ones and 4 of those ones because it's still just 9. It's always just 9. Okay, there's 9. Well, we're just going to break those 9 up. 1, 2, 3, 4. 1, 2, 3, 4, 5. It's still just 9. You're just changing how many you're grouping together. So, I mean, what about 3? 3 and 6. 3 in the red group, 6 in the green group. Still just 9. I mean, how about we do 7 in the red group and 2 in the green group? Still just 9. No matter how many times these are all the different ways that you can group this. So me writing these out is me saying this. We have 9 ticks. We're just using these numbers to represent, these are symbols, they're squiggles. What they actually represent is a value. And so that value of 9, numbers represent things. And so things are tangible things. And so we have 9 things. The number doesn't change, but you can change the way you group them together. So anytime you see a number, think of it like this. Because the number 9 really means 9 ones. Everything's a 1. So this is 9 ones. Think of it that way. Okay, and when we have 9 ones, we can group those ones however the heck we want. The quantity 9 is never going to change. It's just the different way that you group them together. So you have 17 ones, and you're subtracting 9 ones from them. Okay? Well, how about we decompose this 9 and make it easier to work with this 7? So, what way can I group 9 ones together? I'm going to break this into 7 plus 2. Right? That's the group that I'm going to use. 17. Well, I'm sorry. That's the group. Minus 7 minus 2. Sorry, I wrote it confusing. I'll write this a bit bigger. Okay. 17 minus 7 is 10. Minus 2 is 8. 17 minus 9 is actually 10 minus 2. That's it. You take, when you have anything in the tens place. So, because we have 1 here, and we know that the number that we're going to be subtracting is going to take us out of the tens place, because this 17 is here, and we're going down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that we're going to make that 9, 0 jump. We know that we're going to make that jump when we're subtracting 9 from 17. Because we know that 7 minus 9 is actually 8. Because we know that, because of spiral dynamics. So 7 minus 9 is 8. We're going to make that jump. So how do you break this 9 up into something to get you to a 10? You break the 9 into 7 and 2. Because 17 minus 7 is, and then working from 10 down from there is a lot easier to work with than trying to think of what's 9 away from 17. You just say no. 17 minus 9, well, 9 is a 7 and a 2, so I can do 17 minus 7, and that just leaves me 2 to subtract left over, and that's just 10 minus 2. You can just decompose numbers. When the lady she asked me, what's 23 minus 8? Well, I can just decompose that, because 8 is 5 and 3. And what's 23? It has a 3. So, and if you know how to count by 5s, well, you already know it. But you can just decompose it. It's another way of doing it. So, decomposing numbers. I'm done. Every number can be represented by any group. You can use any way to represent any number. An equation? When somebody writes out an equation, I don't know, it just looks like shit. This is just a different way of representing a number. Like, that's all equations are. It's just different ways of representing a number. Because 2 cubed, that's just a different me writing out 2, if you can see it, is equal to 8. When I write 2 cubed, what I'm saying is 8. Anyway, you can represent any number an infinite amount of ways. You can represent sorry. I know that got confusing for a second. I can be confusing. 5 can be 15 minus 10. 5 can be 25 minus 15. 5 can be 2 plus 3. 5 can be 9 minus 4. 5 can be 13 minus 8. 5 can be 19 minus 14. 5 can be 1 plus 4. 5 can be 5 plus 0. 5 can be negative 2 plus 7. 5 can be the square root of 25. 5 can be whatever the hell I want it to be. I can just decompose a 5 into whatever I want. I could represent 5 with a subtraction problem if I wanted. What's 2 plus 5? I keep on screwing up my 5s. What's 2 plus 5? Well, how about I represent 5 with 12 minus 7? 2 minus 12 minus 7. That's a different way that I can write 5. You can write 5 however the hell you want. That's all I'm getting at. So you can write 9 however the hell you want. You could write this 17 minus root 81. 17 minus the square root of 81 is just a different way of writing 9. That's all. So you can represent numbers however the hell you want. So with adding and subtracting, decomposing numbers to break it into something that's easier to work with, you just take 2 steps instead of 1. So with 17 minus 9, I have 2 steps instead. I have 17 minus 7, and then I have 10 minus 2. So 17 minus 7 equals 10, and 10 minus 2 equals 8. So I have 2 simple addition problems to do instead of 1. But it's easier to think of, how do I get down to the closest 10 and then whatever's left over. It's easier to think about that way. Decomposing numbers.